Hello everybody, and welcome to the BYO keyboard programming tutorial. So today we're going to talk about breadth versus depth and kind of how to mentally prepare for parts 2, 3, and 4. So in part 2, we're going to look at an intro to programming. Part 3, we're going to look at an intro to microcontrollers, and then we're going to combine parts 2 and 3 together and apply that knowledge that we've learned to the BYO keyboard. So on the topic of breadth versus depth, these topics that we're about to see could be several careers. You could be a software engineer, you could be an embedded engineer, you could be a research and developer, a prototyper. You could do all the things. I myself do all the things. I don't do them well. But everything you see here, I'm self-taught. And so I've learned all these skills and they can be learned. If you want to pick any of the skills, could be like a full career though. And so like I myself, by day job, I'm a software engineer. So that's where I go really deep and I learn things. When I was trying to make this presentation, I found it very difficult because there's a lot to cover. And it's like, how deep do you go on a given topic? How wide do you go on all the topics? And so we're going to cover a lot of things today. And all these things I've acquired over probably the last 10 years of my life. So don't feel... You're probably going to feel a little bit overwhelmed. And I think even as I was making this presentation and creating the resources for today was also feeling a bit overwhelmed. So something to keep in mind of is like, there's a lot to learn. It's a fun journey though. Just take it one step at a time, be patient with yourself, find the resources and the support network that you need to get through it. Because there are some tough challenges, but if you exercise your muscles and get over those tough challenges, it's very rewarding on the other side. Like the BYO keyboard, all the parts that go into this, I'm self-taught on. And I think that is very rewarding. And I love it. And I hope that I can share kind of some of my enthusiasm and excitement and passion for this topic with you. So breadth versus depth, keep that in mind as we're going through. We're going to go real shallow today, cover a lot of stuff very quickly. All right. So the first part, we're going to start with a little intro to programming. So in this, we're going to install BYO, and BYO is the software of choice for running CircuitPython, which is the part of Python that runs on microcontrollers. And we'll get to in a later section what even microcontrollers are. We will set up the itsy bitsy MO Express, and this would go in another section, but we're going to start writing some code on the itsy bitsy right away. And so we want to set it up first. We'll learn about the BYO software and what it does and how we work with it. And then we'll write some basic code. Learn some basic stuff, and that will be the overview for this section. So let's switch over. So we're going to start by going to code with .mu, and you can hit the download button and you can find your appropriate installer. I've already installed the BYO, so I'm not going to do that. It's already set up and running, so I can go ahead and open it. And you'll probably get this message because we haven't set up the itsy bitsy yet, but it says could not find a device locally. That's all fine. So yeah, so we'll leave that down for now. So now that basically it's downloaded, click the installer, run through the steps, and then you'll get to here. So up next, we're going to set up the itsy bitsy MO Express. And so to do that, we're going to go to circuitpython.org. And we're going to go to the downloads page. And we're going to search for itsy bitsy MO Express, which will come up right here. And you want to make sure you don't pick the M4. You can kind of think of M4 and MO as like downloading software for a MacBook when you have a Windows computer. M4 and MO are very different. So we're going to go with the MO. So make sure the MO Express. And we're going to use 6.3.0. If you're watching at a later date, you might have a different version to download. But yeah, so we're using the 6.3.0. So we're going to download this .uf2 file. And I'm going to close out of my notes. Drag this to the desktop. And then I'm going to go ahead and plug in the microcontroller. And depending on your computer, you might pop up and see a folder come up. So this is my folder popping up. And so I've already been playing around with the itsy bitsy. So you're probably going to see something different here when you plug it in for the first time, but that's okay. So now that it's plugged in, if you look on your itsy bitsy, opposite where the USB connector is, there's a little button that you can press. And if you press it once, you'll see right below the button, it says reset. And so if you press it once, it'll just reset it, disconnect it, bring it back up. If you press it twice though, at a certain rate, so I'm going to say the press is out loud, press, press, it comes up in this itsy boot mode, which is a different mode. And if you, so I hit reset again. If you don't hit it correctly, like you hit it too fast, like I just tapped on the reset button, it comes back up and it's not in the boot mode. So it's like tap, tap. It's weirdly a thing that takes a little bit of skill, but 2 taps on the reset button, tap, tap, and we'll get into here. And you can see current UFT is basically like the operating system. Microcontrollers don't quite have operating systems, but you can kind of think of it like that's the operating system. So that's the current one that came installed, and we want to get it up to 6.3. So with this UF2 file, we'll just take it and we'll drag it. And when we drop it in, once it gets copied over, the itsy bitsy will reset. And now we are up and running with 6.3. So if we go back over to the MU, we can now load code from the itsy bitsy. So you want to go down and select the USB drive. That's for the itsy bitsy. If there's no code file, you can create one. So you can go new. So let's just go back over as an example. If I'm going to delete this, and so say we didn't have it, we could just do new. Let's close out of that. We go new, and then if we save, it's already pointing here, and so we'll just call it code.py, and it already has the extension, so we don't even need to do .py. Save that, and now our code is running. We're good to go. So that is setting up the itsy bitsy MO Express. Now let's learn about MU. So MU is a text editor. You basically write your text down, you write your code down here, and we'll run through the buttons. They're a very simple selection of buttons, which is pretty awesome. The mode, there are other things you can do with the itsy bitsy. We won't explore those, but we're going to keep it on CircuitPython. I already have it highlighted, so I'm just going to close out. New to create new files, load to open a file, save to save the files, pretty basic operations. Serial is the way of communicating with the itsy bitsy. There's a special mode which we'll look into that lets us write code and run it kind of live without having to save files. Plotter is a more advanced feature, but basically if you set up your itsy bitsy to send numbers back, maybe you have a sensor that's reading temperature, you can actually just turn it right into a chart that you can visualize. These 3 are for making the text bigger and smaller. Make it a little bit bigger for the video. You can click through here and change the themes. And then there's some helpful tools that we'll explore a little bit later, but check will make sure that if you hover it, it'll tell you checks your code for mistakes, and it'll give you some helpful error messages. Tidy will kind of clean up your code. So if you're kind of sloppy writing code, it'll clean it up for you automatically. I actually get in the habit of writing clean code that is well structured, but this little button will help you out. And then help, which I haven't really looked into, and quit will close out. This is basically what the MU does. All right, and so we'll write some basic code. So if we go over here, and we're going to come back, we're going to start with the serial. Before we write our code here, we're going to start with our serial. And so serial gives us access to what's called REPL. And REPL stands for read, evaluate, print, loop. So the read part says you type in some code and it'll read it. The evaluate part will then actually run it. The print part will output the value of the evaluation. And then loop just means let's start again and we'll wait for some more code to read in. Excuse me. So if we come down here, we'll see that auto reload is on. So every time you save the files, they'll run, or you can enter the REPL mode to disable. And it says down here, press any key to enter the REPL. So for whatever reason, clicking down here also counts as typing a key. And this is actually some weird code of what clicking does. So we're actually just going to delete that. All right, so now we're good to go. This means we are in the REPL. These 3 right angle brackets mean we're in the REPL. And you can see that we are in CircuitPython 6.3.0, which we downloaded, running on the Adafruit Itsy Bitsy MO Express. Now, just an interesting bit to note here is that even though we see the code, like this file, this code.py file is open on our computer, it's actually on the Itsy Bitsy. Same down here. Any code that we run actually runs on the Itsy Bitsy. And so for those that are coming from writing Python on the computer, this is an important distinction. This is not running on your computer. So serial is actually the way that, we won't dive too deep into serial, but serial is the way that is the communication that's actually happening between the Itsy Bitsy and your computer. It's happening via serial communication. So we're seeing a serial communication here. And so the code runs on the Itsy Bitsy MO Express, and then the result, the print part, will print the value back out via serial from the Itsy Bitsy. So you can read more about serial. We won't go too much into that. All right, so what can we do with this blinking cursor down here? So we can start out with the most basic. We can do some math. 5 plus 5. So this is, we are writing, we are reading in. When I hit enter, it gets evaluated, and then it prints out the result, which is 10, and then it loops through and starts again. And so these are our first, there are what is called types in programming, and there are many types, and we will see a few of them today. Integers is the first type. So 1 is an integer, 2 is an integer, 3, 10, -1, 0, all integers. And so that is a type that we will see in programming, and we'll get to a few a little bit later. The next up helpful bit is the print function. And so functions are basically, and we'll actually look at an example of a function later on, but there are ways to write a piece of code, save it, and then we can use it to help us do other things. And so the print function actually lets us print out random things down into the screen. And so print is the function, and we use a function by adding parentheses, and then the data we want to pass into the print function goes in the parentheses. So this gets us to our next data type, which is called strings. And strings is just basically a collection of human readable text that can either be put in single quotes, sorry, these are double quotes, either in double quotes or in single quotes. So we can print a message like hello world, and then it prints out. And you'll kind of be wondering, like, what's the difference between the two? And we'll explore that now. So what if we wanted to print out that the message 5 plus 5 equals 10? We can pass in multiple pieces of data into the print function separated by commas. So we could do the value of 5 plus 5 is, and so now we have our string here, and so this is going to print out directly, and then we can do 5 plus 5, and this will add that together, and then it'll leave 10 here, and then it'll print out the value of 5 plus 5 is 10. Up next, we have variables, and so variables are similar looking to strings, but very different. So if we want to store a value, we're going to give a name, we're going to set an equals, and then we're going to put 1. So we're going to say value is 1. And if we want to see what value is, we could call print. We get 1. We could also do the value of value is value. We get 1 here, and we get a string here. And then also, interestingly, just to show you, the difference here is that this is a string, and this is a variable that points to the integer 1. So we print that out, we'll see value the string, 1 the variable value. So these are some basics of the REPL. And so now we want to jump over to writing some code up here that we can actually run down here. So I don't know if you saw earlier, but Control D is the command to exit out of the REPL. So if we hit Control D, we'll now see that we're in auto reload mode, and simply save any files, and they'll run down here. So nothing to run up here. So if we delete this out, and we'll start, and we can just basically kind of copy what we had up here and we'll say value, say equals 5 plus 5, print the value is, and if we save that, so I just hit the save keyboard shortcut, but you could also click up here, it's run, and we could say, see the output code.py, the output is, the value is 10. Sometimes be careful when you click, so I just click, so I'll just delete what's in there, and I will hit Control D. Another little tip is you can actually, when you have stuff in here, and you don't want to backspace all the way, you can hit Control C, and it'll clear it out, and then you can hit Control D, and you'll see me use that keyboard shortcuts a lot. Control C, then Control D. All right, so we'll save again, we'll run, we'll see that output is there. All right, so let's start to get into some interesting bits of, some other interesting bits. So comments let us give human readable instructions. So these won't actually get run by the itsy bitsy. So when it sees the pound symbol, it won't run anything after it in that line. So I can type whatever I want up here. This is my first code. I can hit this Control Save keyboard shortcut. It runs, nothing changes because this code doesn't run. We could also similarly come down here, put a pound sign here. And if we save that, we'll see that the output is nothing because we've commented out this code. This code does not run. Also, we could comment this out. And this gets us to our first error. So computers are pretty dumb. They just do what they tells you to do. And so if we say ignore this line of code and ignore this line of code, it'll get down here and it'll try and print this, which is fine. It's a string, but it'll try and print value. It'll be, well, what's value? I don't know what value is. And it even tells you, it says there's a name error, value is not defined, and it gives you some helpful bits. So it's useful to read this. File code.py, which is where we are on line 3 down here. Value is not defined. And I haven't explored this check button too much, but I think if I hit this, it'll actually tell you, yeah, well, that's a separate issue. But down here it tells you undefined name, value is not defined. So we can uncomment this and save our code, remove the checks so we can clean it up a little bit, and then we can run it again. Whoop. And code is done running, the value is 10. So those are what errors are. When we have code that we run that has errors in it, it's useful to try and get into the habit, and this is a skill that you develop over time, of trying to figure out what bits of the error message are useful if you get stuck and you need to go to Google to figure out. So these 2 lines are pretty generic. It's just telling you that there was a traceback gives you all the errors that happened up into the error that you got. And so we got one error, and this tells us where it is, but that's specific to our code. But this is the issue that we're confused about. And so maybe if it wasn't so easy, hit Control C. I want to highlight it and right click to copy. And then I can go to Google, I can paste it in, and you'll get a great website called Stack Overflow, which is a great place to go when you're confused about programming errors. And it looks like we've hit an exact match. And you'll see a bunch of text. And this is the amount of upvotes or downvotes that the question got. So sometimes if it's heavily downvoted, or if we scroll down here and the answers are downvoted, I'll go somewhere else. But yeah, you can read through the answers, and if they're not helpful, maybe go on to a different answer. This one doesn't even have an answer, but yeah, this is a very simple error, and we actually already know how to solve it, which is why on simpler errors you might want to avoid Google. But there we go. So those are basic intro to errors. And next we're going to talk about white space. So white space is basically, come down here, a space bar, that's white space, hitting the tab key, that's white space, hitting the enter key, that also makes white space. So this is all, this blue bit that you see hovered here is white space. And Python uses white space to do some interesting stuff. And when we get into some other topics, you'll see this. But one error you might get is that if your code's like this, that's not actually valid code, because the white space kind of says that these are 2 very unique separate things. And so if we save that, let's exit out of here, we'll get an error and it'll say unexpected indent, line 3. And so that's what that is here. So indentation is unexpected, and it should be like that. We save it and run it again, we'll get out our value as 10. All right, so let's get back to the REPL, and we're going to comment out this for now. We're going to come down here, we're going to Control C to clear, and now we can go back to doing some fancy things. So say we wanted to add 3 numbers together. We could type it like that, and we could see it's 13. So if we learned 10 plus 2 plus -2, we could do that as well. You'll notice this pattern where, with what we're trying to do here, and this is a very random example, is we're trying to add 3 numbers together. And so we could keep typing that like this, or we could write a little function, a little bit of code that helps us do this, so we don't have to keep writing space plus space, space plus space. And so what we're going to do is write our first function that adds a bunch of numbers together. And so we declare a function by typing DEF, which stands for definition, and we'll give it a name. And name should include letters and underscores and nothing else. There should be no spaces. Try to avoid numbers. Or I personally avoid numbers, so I can't remember if numbers are valid. But anyway, so we're going to call this function add numbers. And the next part is we parentheses, and this is the bits of data that we want to take from outside of the add numbers function and pass into it. So we'll have number, call first number, second number, third number, and then we do a semicolon. And now we're going to write the code that actually adds first number, second number, third number. So we will type enter, and you'll see that actually we get some automatically added white space here. And what this white space, this indentation here, means is that everything we write on this line will correspond to add numbers. And everything that is down here afterwards does not. So we come back up here, we'll do print, we'll do first number plus second number plus third number. And if we come down here, this will give us, basically, it'll add all 3 numbers together, and we can then use add numbers. And to use it, similar to like the print function, where we passed in our message, we can do the add numbers function. And if we save this and exit out of here, we'll see that the output of 1 plus 2 plus 3 is 6. And we could call it again, or use it again. Call is a synonym for use. Did 10 to -5. Save. We'll see the output of 1 plus 2 plus 3 is 6. The output of 10 plus 2 plus -5 is 7. And so this is the basics of functions. Now, what if we wanted to add another number? So what if we wanted to add 4? If we save that, we get another error, and it'll say function on line 9 takes 3 arguments, positional arguments, before we're given. And this is the helpful message. So arguments are the bits that we pass in. The function takes 3, first number, second number, third number, that's 3, but it got 4. So this is going to introduce us to our next concept, which is called arrays. So we'll comment this out for now so we're not getting errors. We'll come down here so we can enter into the REPL, Control C to clear out, and we will talk about arrays. So an array is a collection of things, and we add square braces, and then we comma separate our collection of things. And we could even assign it to a value. We could say x equals 1, 2, 3, and then we could print out x, and we see that it's 1, 2, 3. So what if instead we set up add numbers to take in an array of numbers instead of 3 individual numbers like this? So we can delete what's in here, and we'll call this now numbers array. Actually, let's leave this up here and let's duplicate this. And we'll call this function add numbers array, because each function and variable needs a unique name. And we'll put in here, instead of this, we'll put number array. Now, instead of doing this, we're going to introduce to a new concept, which is the idea of a loop. And a loop is just kind of similar to what we saw in the REPL. Read, evaluate, print, loop. Loop means go back to the beginning. And so we're going to loop over a collection of things. In this case, we're going to loop over the numbers array. And to add each number, we're going to go, all right, we're going to start with 0, and then we're going to add 1. And then we're going to have 1, and we're going to add 2. And then we're going to have 3, and we're going to add 3, and we're going to get 6. So the way we write this is to write a for loop for an array. We can do for number in array. Sorry. So this is the syntax for it, and then we have access to number. So if we want to like print number, We can start here, and if we save this, let's comment this out so we don't run this and get that output to the screen. And this time we're going to pass an array of 1, 2, 3. Now if we save that, Control D out, we'll see array is not defined. And that is a helpful message. We can see it starts at line 14 and then goes to line 12. So that's helpful that line 14 calls add numbers. So we go into here. Then line 12, we've used the wrong variable name. So let's just rename this array. And if we save again, we will get but print out numbers. And just to see that like something else isn't happening, we can see 3, 1, 2, 3. All right. So to add the numbers, we want a place to store them. So we'll start out with a total. Say that's equal to 0. And for each number, we want to add it to the total. So we'll say that the total will be equal to the old total plus the number. And we'll add little print statements just to say, to help us see what's going on. The array is number array, print. I don't think we need the total because we can see that it's 0 there, but if we come in here and we enter, we'll print the number. Actually, let's get number, total. Don't need the quotes. Cool. So the number will point to what the current number is, the total will point to what the current total is, and then when we're done, we will print out the total. The final total is that. And you'll notice again that I forgot to call out is that we can see some more indentation here, and it says that lines 15 and 16 correspond to the for loop, but line 17 does not because it's on the same indentation. And we can see that lines 12, 13, and 14 belong to this function. And since 15 and 16 belong to 14, 14 belongs to 11, you can say that 15 and 16 are also within this function. So everything in here belongs to this function add numbers array, and since we're back out here on the same indentation, they don't belong to each other. They're separate bits. So let's save and run, and we'll see that we start out with the array is 3, 1, 2, 3. So the array is 3, 1, 2, 3. The total is 0. So we'll start out with the first number 3, and the total is 0. So that's what we see here. And then we take 3 plus 0 equals 3. And now it'll come back up to the beginning because there's still numbers to be processed. So we'll get to 1. And then actually to make this make more sense because we do the calculation after, let's move this after the loops. This makes more sense. We'll delete this line, put that in there, save it again. So this should make more sense. So now, so the number is 3 and the total is now 3. The number, oh, sorry. And then we get to the next number, which is 1, and we add that. 3 plus 1 is 4, and then 4 plus 2 is 6, and then 6 plus 3 is 9, and then the final total when we output is 9. And so this is what a function does. And lastly, if we want to, we're outputting information to the screen, but we're not actually using that data, the add numbers array data for anything. And so the last bit we need is return. And what return does is it says, let's take this value total, and you'll see that total currently belongs to 11. And so we want to have total available to the outside world so that it's accessible by other things. So we could do something like this. The first total is, and then we could print the value out. And now we can get rid of, I like to keep print loops in, or sorry, print statements, print functions like this in when I'm writing code. But when I know it works, comment it out or delete it. And so we'll just comment it out, save. And if we clear and restart, we'll see that the print down here is 9. And we know that 3 plus 1 plus 2 plus 3. And we could add another function like, sorry, another usage of the add numbers array where we add like, and we could say first total plus second total. And now we'll calculate 3 plus 1 plus 2 plus 3, and we'll get first total. And then we'll calculate negative 3 plus 2 plus 4, get the second total, and then we'll add them together. So that should, 3's cancel out. 1, 2, that's 6. Sorry, I said that in a weird way. 9 plus 3 should give us 12. So we save that and we run it, we get 12. And then you can imagine that we have other functions that we can combine together, and that's how we start to write functions that, like, now we can use this bit of code. Let's delete the comments so we can see it all on the screen at once. We could use this function. We could have some other functions as well so that we don't have to keep writing this to add numbers that are in an array. So that is the introduction to functions and arrays. Now we can use them. So that covered the basics that we need for before we jump into, let's jump back to the PowerPoint. We can see where we're going next. All right, so in this section, we installed Mu, we set up itsy-bitsy Express, we learned about Mu, we wrote some basic code. That was a lot very quickly. I think myself, it took me probably like 6 months to a year to learn all of that. Sorry. Yeah, maybe 3 to 6 months actually, to like really learn all of that well. And there's a lot of other concepts that we didn't even touch on today. But that's a brief introduction. And so don't think that you didn't get all of that today. Don't worry. I would highly recommend, if you want to learn more about programming with Python, there's a great book called Automate the Boring Stuff, which you can actually see for free online. And you'll start to see some of the stuff that we talked about. So going to like Python basics, you can see we were learning that stuff earlier, and like there's so much more to read. But I highly recommend this book, automatetheboringstuff.com. Buy a copy of the book if you can. It's a great book. It's still on my bookshelf. Highly recommend it. So, and also, sorry, I should make a little call out that Automate the Boring Stuff is for Python. CircuitPython is very similar to Python, but not exactly the same. So if you're going to use this book, it'll actually tell you how to set up Python to run on your computer. Remember, all this code that we wrote here is running on the itsy bitsy. But definitely the first probably 6 chapters would be incredibly helpful for writing code with the itsy bitsy. And then you can also get code if you go back to the Adafruit website. So if you Google itsy bitsy MO Express, you'll get the product page, a bunch of details. And if you scroll down, you have a learning section. And if you scroll down, you'll see a bunch of different guides. So like CircuitPython Essentials is a great place to start. Some other tutorials like introducing the itsy bitsy MO Express. This is a fantastic place to start, which you'll get CircuitPython Essentials, basically everything that we're covering today, but in a lot more depth here. Okay, so on to the next section, Intro to Microcontrollers. So we'll talk about what is a microcontroller. We'll learn a bit about the itsy bitsy MO Express and a whirlwind of stuff on circuits and things like that. So what is a microcontroller? A microcontroller is very similar to a computer, but it's much more basic. It's got less computing power, less memory, less storage space. An itsy bitsy costs $10. Your computer costs maybe $1,000. So the itsy bitsy does a lot less than your computer could. It can run code. So the itsy bitsy can run specifically Python and C++. Other microcontrollers can run their languages. Itsy bitsys give you, or each microcontroller gives you a way to control things in the real world. So lights and motors and things like that. And then it can also receive in data from the world, like from sensors like a temperature sensor or from a button press. And so specifically with the itsy bitsy, we're going to look at how to control the lights on it and then how to read in button presses from the device. And so this is all done via pins. So physically on the itsy bitsy, and you see a little photo over here, those are pins. And then you just see these little descriptions along the side, which say what those pins do, which we'll look at the itsy bitsy pin out, which is a thorough description of what all those do. And as I had briefly just mentioned, inputs versus outputs. So inputs are things that the itsy bitsy receives, like a button press, and then outputs are things that the itsy bitsy controls, like a light. So if we click over here, this brings us back to that page that I was talking about, which gives an overview. Sorry, not this page, pinouts page. This gives you an overview of the pinouts. And so you can read through here about all the different pins and what they do. I'm going to scroll down specifically to the logic pins. And so if you look at this photo here, imagine it rotated 90 degrees to the right so that these pins are on the right side, these pins are on the left side. And keep that in the back of your mind because we're going to come back to that in a second. You'll notice here that we have pins 13, 12, 11, 10, 9, 7, and such. And we will come back to that as well in code. So just kind of keep these numbers in mind. But if we want to control and hook up an input or an output, so we want to hook up a temperature sensor, we want to hook up a button to the itsy bitsy, we do so with these pins. And there are other similar pins that do similar functions along here. And this is kind of pins are the way that through code and through the physical world, everything comes together. So if we say in code that pin 13 is for a temperature sensor, then we connect that pin 13 to a temperature sensor out in the real world. And then we can write a little code that says, we know pin 13 is a temperature sensor. Let's read the values from it. Let's output them to the screen. So pins are the magic point where everything gets tied together. Now I want to jump into a brief history of the BYO keyboard, which will hit on what I was just talking about with pinouts and inputs and all that good stuff. And then that'll also explain a little bit about the code that we're about to write in the next section. So the BYO keyboard kind of starts out as just what's called like the prototyping process. And so I have a bunch of components in bins and such and wires and all this kind of chaotic mess that you see here. And I start to put it together and to experiment. And so what you see here is me with one of the first mechanical switches with a keycap. And then I got some wires that are like connecting it all to a microcontroller in the background. And this is the first photo of the existence of the BYO keyboard, or the first beginnings of prototyping. And so what you do when you have this mess of wires and bits and things like this is once you figure out how to get it all working, you write some code, you have a little circuit that works, you want to make it permanent. And so that's the process of converting it into a printed circuit board, which is, depending on the color, either the black or white plate that you got with your kit. And so remember when I said, keep in mind, if you rotated things 90 degrees right and left, this is what you see up here. This is a schematic, and this is the first part of converting this mess of wires into something more permanent. And so basically what you do is you get all the components that you need. And so here we have header pins, and then you can see K1, K2, K3, K4, K5, K6 are all mechanical switches. And then we have these little bits diodes, which are the little cylindrical tubes. And the itsy bitsy will connect into these header pins here. And we'll see if we'll jump back real quick just to, whoops, sorry. We go back out to the browser, go to here, we'll see 1, 2, 3, fourth down is where these logic pins start. And so if we come back to our schematic, we'll see 1, 2, 3, 4, fourth pin down. And then we use 1, 2, 3, 4, 5 pins total. Those are our logic pins that connect to our mechanical switches. And that tells us how these mechanical switches will get read into code. And so we'll explore this a little bit in the next section. But this is how we go from the itsy bitsy, which would plug into these connector pins, and how we'd connect those to the buttons to write some code to have the switches, the buttons, control something on our computer. And then similarly, this is the process of converting the schematic to the board. So this talks about how all the electrical components will interact, and then this talks about how it'll actually physically be made. So this is basically what you're seeing here is a screenshot of the set of instructions that I send off to a manufacturing company to make the circuit board. And lastly, one bit that I didn't call out is the green and red wires you see here, or just the green wires here. These are known as traces. So in here, you have all these wires kind of up and about and in the air and stuff. Whereas here, they're kind of thin pieces of copper that sit on top of the circuit board. So if you look at your circuit board, you can actually see these. Green is for one side of the board, red is for the other side of the board. And then I talked a lot about the switches, but what are the other components? And so this is a bit of an advanced topic of why are there diodes. But diodes, so I won't go too deep into it, but basically, if you can imagine, each switch would need a pin. Each mechanical switch, we need a pin to connect it to the itsy bitsy. And if you see, there's only the small number of pins. And so there's an advanced topic that basically says that you can put pins into a rows and columns matrix. So you'll see row 1 is this wire, row 2 is there, row 3 is there, and then column 1 and column 2. And basically, instead of having one pin per button, you can have one pin per row and one pin per column. And so I definitely over-engineered this, but this kind of gives you an idea of how like the keyboard on your desk works. Is that if you look at your keyboard, and I'm looking at mine now, it has roughly 10 columns going across and then 6 rows going down. So 6 by 10 gives you access to 16 pins, let you control 60 buttons. So 1, 6, 16 pins let you control 60 buttons, which is pretty cool. So that's what you're seeing here. All right, up next, we're going to look at combining programming microcontrollers and the BYO keyboard together. We're going to do in this section, we are going to start with what is the library, and then we're going to install the needed libraries. We're going to look at controlling the LED on the itsy bitsy. So note in this number 3, we have send output. And then in number 4, we have read input. So outputs versus inputs. And we're going to read input from the mechanical switches. And then step 5, we're going to personalize the BYO keyboard. Kind of do whatever you want. And so we'll use 3 and 4 and what we learned there. Bring them to step 5, do a little bit of Googling to figure out how our favorite software tools work, like Zoom or Spotify or whatever, and we'll control those. So let's jump in. What is the library? So say you have, and I guess we'll just use the dot star as an example. So the dot star is the little LED that is included on the itsy bitsy. And it's a little LED. It can have colors red, green, and blue, and then you can combine red, green, and blue to do fun things. And it's a fancy little component on the itsy bitsy. And say the author of the dot star wants to, or the creator of the dot star wants to write a bunch of code that makes it easy to use. So they'd write a library, and the library is a collection of code that you can bring into your own code and use. And so we're going to look real quick and kind of take our add numbers array as a simple example. So I'm actually going to zoom out just so we can fit a little bit more on the screen. So say you write this great function, add numbers array, and add, maybe a better name for add numbers is actually add 3 numbers. So let's just delete all the commented out bits. And also these executions down here. And we'll save. And we'll pretend that this is our library. And we will control C and then control D, and we restarted. Now let's enter the REPL. So we'll look at the actual installation process in a second. So we'll cover the import syntax here, which is how you actually bring in code from a library or a separate file into where you are. So right now we have the REPL, the read, evaluate, print loop running on the itsy bitsy. And so how might we get the code from this file code.py, which you could pretend that like this is a library. So maybe actually that's fine. We'll just leave it as is. So what you can do is you can type import and then the name of the file or the library, and you'll get everything in it. Or you can import specific things. So import, from code import, and then whatever you want to import. So I'm hitting Control C just to end the line and go to the next one. So we could do import code. And what this line here does, actually, let's reload just so we're back at the beginning. Pretend like I didn't just type that. So we're back at the beginning. So I could do add numbers array. I'll do 1, 2, 3. You'll see that it's actually not defined. Name error, add numbers array is not defined. It doesn't exist. So how do we make it exist? So we can do, if we think about it, if we open up a new File Explorer, bring that on. So this code is kind of running like alongside where this code file is. So if we type import code, we can actually now do, actually I'm going to Control C and show you a fun little trick. If you hit the arrow up key, it'll go back to code you've already written. So we'll see add numbers array, we can hit it. Interesting. Let's see if this works. There we go. Okay. So what just happened is it actually, this is a bit of an advanced topic, but so you'll notice here that hopefully this explains. So import code just basically imported all of it, but I think under code. So I think if we call add 3 numbers, this won't work, but we do code dot, yeah. All right, so we're gonna Control D, we're gonna reset everything, we're gonna start again. So basically what happened is when we imported code, every function here is actually now to use it, you have to do code dot. So code dot add 3 numbers, code dot add numbers array. Or you can do some fancier syntax from code import star, which will grab everything in here and just throw it in and ignore the code dot. And so now we can do add 3 numbers array. Sorry, add 3 numbers, and it'll work. And then we can also add numbers array. That'll work too. So anyway, imports are a little bit tricky, so we won't go too deep into that today, but that's basically what was happening there. So this is how we get access to a library. So now let's actually go ahead and install the libraries we need. So to do that, we are going to go back to circuitpython.org, and we have this libraries folder, and we are using version 6 of that UF2 file that we downloaded earlier. So we're going to download the 6th version. Once that's done, let's see here, 6.3. So the 6 should correspond to the bundle version, and we want the MPY files. So down here, there's a PY files. MPY are files that are run on CircuitPython. So we want those. So we'll drag that out here. I believe this process takes a little bit, so we will let that run. So basically what we're getting here is a collection of a ton of libraries. And we can actually go read about those libraries if we go to the libraries page. And we can find descriptions of all the different libraries that are included with what we're downloading right now. So everything from distance sensors, so sensing distance, to light sensors, to what do we got? Pressure sensors, motion sensors, working with e-paper and e-ink displays, lots of other different things. So that's what we're getting here. Now, still copying. All right, so now that we've extracted it, we have this, and we can click into lib. And lib, if we open up our itsy bitsy, we'll see that we have code that we've been running. We have this lib folder. And so I've already copied things in, so I'm just gonna delete and pretend like I didn't do that. All right, so what we're gonna want from this list is we're gonna want Adafruit HID. HID stands for Human Interface Device. So an interface device is a device that, a HID is a device that you use to connect to the computer to interface between like a human and a computer. And so a keyboard is an example, a mouse is an example, the monitor is an example. And so this is a collection of tools. Sorry, actually, I don't know if a monitor is an example. I know a keyboard and a mouse are. I think things that connect via USB. So the HID library is going to let us turn the itsy bitsy into a keyboard. And then we're going to want the matrix, Adafruit matrix pad. Matrix keypad, sorry. And this is a little tool that, if you remember that advanced topic of rows and columns that make up, that's like a matrix keypad. And it simplifies the code of trying to read or figure out which mechanical key is being pressed. And then last we have the .star library, which is the LED that comes on the Itsy Bitsy. So now our code is ready to go. Our libraries are ready to go. Sorry, I should say our code is not ready to go. Our code is ready to use the library. So we can close out of those windows. And let's jump back into the presentation, which is basically just an advancement of the next slide of, sorry, we've already installed the library, so we've done that. And now we're gonna look at controlling the LED. Sorry, I'm missing a bit, and then we're gonna read input from the mechanical switches and then personalize. So if we wanna send output to the LED, and the LED is known as the .star. I was actually Googling earlier. And so we have the CircuitPython .star, which this is found within the introducing the Itsy Bitsy MO Express. And so this will tell you a lot about what it does. This is not actually the code I want, sorry. Let's start in here. So this was from the CircuitPython page, the libraries page. And so if we search the page for .star, this will give you an overview of how to install it and how to use it. So this is some basic code that we should be able to now copy. So actually we'll split screen. And it tells you that this will run on the Trinket MO and the Gemma MO, and I believe also the Itsy Bitsy MO. So if we come back here and we come in here, we can type these lines out, or we could type them up here and save them and run. But I want to actually, let's start up here. Let's just paste it in here to see how things are working. So what this code does is we're looking at import statements. So it's importing the libraries that we need, and then pixels. So there's a single pixel. So how we use a library, so this library is the Adafruit .star, and we want to use .star, which is more advanced syntax, but that's basically how we use the library. And we'll say on the board, we want to use pins APA102_SEK and APA102.mosey. And if we actually go back to the Itsy Bitsy MO Express kind of pinouts, actually, let's just look at them in the slides. We should be able to, find that pin here. And actually, interestingly, it says that the dot is accessible by doing all this, which is the same that we have here. So the dots are actually, that's funny. This is how you would have gotten here. So within the pinouts, it talks about the .star and how to connect to it, and you can run some basic code, which is what we have here. And pixels is an array, and so the way you access items in an array, which I didn't actually talk about, but I talked about how to loop over an array. So we have an array of 1, 2, and 3. We do x of 0. And in programming, everything starts at 0 instead of 1. So 1 here is, actually, let's pick different numbers just to make this more clear. Okay, so the arrays start at 0. So this is 0, this is 1, this is 2. So we do x of 1. This is how we go into an array. So pixel is an array, and x of 0 will say the 0th item in the array. And since we only have one LED, that would be the 0th item. So if we actually do x of 0 here, it'll be 2, 3, 4. X of 1 is the next one. X of 2 is the next one. So we have 1 pixel, and we say that by this number 1. These are the pins on the board where the .star exists, and we'll set it to RGB values. And so if we save that, we can see that the color changes. We could also bump it up to, I think we're having some issues. One moment. Okay, so here's an interesting bit of, if you're following along with me, you'll probably notice that before I type this in, it might have very quickly flashed to red. And so just real quick, RGB, red, green, blue. So 255 says we're going to max it out with red. no green, no blue. And it flashed really quickly for red and then stopped. And that's because actually we'll notice down here that the code finished running. And when the code finished running, it kind of reset back to a different state. And so what we want to do is that we could actually take this, put this here. And while true is a different way of doing a for loop. So for loop is like you iterate over each thing in a list. A while loop will keep running until the condition here is false. And true is another type that you haven't seen yet. So we've seen integers and strings. And Boolean, true is a Boolean. So Booleans are either true or false. And you can do some basic stuff like, here you go. Is 5 greater than 2? Yes, that's true. That's a Boolean. So 5 is indeed greater than true. Sorry, 5 is greater than 2, whereas you do it the other way around. Oh, interesting. Wait, why is that true? Oh, sorry, because I flip both sides. Is 5 less than 2? No, it's not. It's 3. If you wanted, just kind of tangenting here, but if you wanted to compare two things, you do double equal signs. Is 3 equal to 3? Yeah, it is. Is 2 equal to 3? No. So it's false. So all true. So this will always be true because it says true. And it'll just keep running. This while loop, the code, this code here belongs to the while loop. It'll just keep running and it'll just keep setting the 0th pixel to red here. So we can import another library, and this library actually comes pre-installed, is the time library. And we can do time.sleep, which will sleep for 1 second. It'll say don't do anything for 1 second. So what we can do is if we repeat this 3 times, we can actually have it cycle between each of the colors. So it'll set it to green and then, sorry, to red and then green and then blue. And so if we control C and control D and then save, red, green, blue, red, green, blue. So it'll just keep repeating. And this code makes more sense than just having this, which is kind of weird. So there you go. So this is how to control the LED. So values can go from 0 to 255. So I think if we wanted to do like red and green would make like a yellow. Red, green, and blue. What green and blue makes purple, I think. No, red and blue make purple. Makes teal. This makes teal. This would make purple, I think. Anyway, you can play around with this, or we can similarly, if we uh-oh. A little stuck. Let's restart the device. Okay. Lost control of the serial. I'm not sure what happened there. It seems to be stuck in here. All right, so for whatever reason, I can't stop it from running, so I'm actually just gonna comment all this out. And now I can interrupt it. Okay, so the while loop just keeps running forever. So it really runs forever. So we said stop running forever. Okay, so now we can type down here. And so what we're gonna do is actually gonna import all these things again. So I believe you can just copy them multiple lines, paste in, and all the things are imported. And then we can do this, copy this as well. And now we can actually just do the same stuff instead of having to do the while loop. Oop, if I can spell, missed an S. There we go. So now it just stays on actually forever. And so here you can do fun stuff because the code doesn't stop running. So you can play around here with like different colors. That's white. I think also you can do, I remember from the dot star code, you can do brightness. If you send a tuple, so tuple is similar to, sorry, I should have highlighted tuple, and I won't go into differences between arrays and tuples, but tuples are very similar to arrays, but they have parentheses instead of square braces. So you can send a tuple with 4. So if you send a tuple with 4 values, you can control the brightness value, which appears in dot star. For example, the brightest red, 100, 0.01. Oh, sorry, that's the brightest red. This is the dimmest red. So if we do 0.01 as a fourth value down here, so yeah, it almost shuts off actually. And I can see it getting brighter as I look down on it on my desk. Oh, it has to be a... Okay, there's another thing. Gosh, we're crash course and covering a lot today. Floats versus integers. So a float is basically, this is the name for a number that has a decimal point. So this is an integer because there's no decimal point. This is a float. And as we read in here, it said it should be a float. So what I noticed here when I sent this to the microcontrollers, it actually turned off. So always needs to be a float. That's a weird behavior, but okay. So I like to keep this. When I was playing around with my own BYO keyboard, I realized that I'd like to keep these values really low. It looks like the threshold for the light turning on, at least for mine, is 0.04. Anything lower than that, like, basically turns it off. And I wrote actually some code to toggle between different keyboard layouts. And I used the pixel to tell me which keyboard layout I was using. So I could say, like, green is Spotify, blue is Zoom, red is, I don't know, something else. Anyway, so that is how we control the LED. Let's jump ahead to reading input from the mechanical switches. All right, so for this step, let's clear out the code. We want to look at the matrix keypad library. So I lost my way, but I'm going to go back to CircuitPython. We're looking for the matrix keypad. Here we go. So the concept that I talked about earlier here of the rows and columns is a little bit complex and kind of annoying to think about. And so luckily for y'all, I actually figured it out. And we can check it out at github.com/painlessprototyping. And we're going to click on BYO keyboard code, BYO sample code, CircuitPython. And we'll start with the most simple of serial communication. So we'll copy this. If we paste it in here, you read through, you'll notice we have some comments. And so what this says is uncomment the following code for the 6 key. And I have the 6 key, so I'm going to uncomment this. And then just delete this because I don't need the 9 key. So basically what I'm going to breeze over this because this has already been figured out and you don't really need to think about it. But if you want to, I invite you to. Let's actually delete all the other codes so we can look at the matrix keypad in isolation. So basically what this does is, if you remember, we talked about pins 11, 12, 13, and then 9 and 10. So the columns are made up of 11, 12, and 13. The rows are made up of 9 and 10. And then the actual keys, when we press any one of those buttons, so this looks like your keypad if you have the 6 key, is at the first row 0, 1, 2, keeping with that items in programming start with 0 instead of 1. And then the second row is 3, 4, 5. And then this little Adafruit matrix keypad library takes the rows, the columns, and the keys. So the rows, the columns, and the keys, and combines them all together. And what we do is we have a while loop, so this code will run forever. And what it'll do is it'll read which keys have been pressed. And if keys have been pressed, we will print them out. And we can see that down below. So if we save this, Control C, Control D. All right, so nothing's happening. But now I'm going to press the top left key on the keyboard. See 0 gets pressed out. If I press the first 2, first 3, all of them at the same time. And so now you have the data coming into our computer. And we can do something with that. So that is how we use the matrix keypad. If you want to read more about this, I invite you to, but we're going to continue on and not get too deep into this because it's a little bit more of an advanced topic. All right, so up next and last up is we're going to figure out, so we can read stuff from the keyboard, we can control values, and we're going to combine it together with the code. Actually, we're going to switch out of here to a different example. So key presses is the next basic example. And this library, copied all of this, not the last line. So I'm going to do that again. There we go. Paste it in here. So again, we're going to uncomment the rows that we need. Delete these lines. All right, so we have our imports up here. We've already seen what time does, what board does, what this does, and that does. Up next, we have the USB HID, as we talked about with human interface devices, and then some other helpful imports that we can use. So here's our keypad configuration. And then here's where we declare our HID. So we're going to use a keyboard. And these are the collection of key presses. And since we are only using 6 keys, we're going to use 1, 2, 3, 4, 5, 6. And these are key codes, or the key, like the actual keys. So like this will print out the value 1, or not, it'll type the value 1. So there's a difference between printing and typing. Printing will just send the data, whereas typing will actually, printing will send it out, or sorry, printing will send it for display, whereas typing will actually, like, you can hit the key and it'll type out. So this is an array, and we are going to use 6 keys. The values number 1, number 2, number 3, number 4, number 5, number 6. We saw this same while loop from our previous example where we checked which keys are being pressed. And for help, we're going to print out the keys so we can see them down here. And then for each key, we can use the keyboard.send. So the keyboard library lets us send whichever key is being pressed. So if we comment this out real quick and save, we'll see that we are back here where I press the top left key and it's 0. And so that's what's printing out. It's an array of keys because we have a keypad matrix. And so that's an array of keys. And so what this next bit will do is we've already seen for loops. So for each key that is being pressed, so if just the 0 key is being pressed, we will look up available keys. We will see the 0th key, which is this one, which is 1. And then we'll put 1 out to the keyboard here. So if we type, or I should save this. I didn't save it. Also, if you didn't know, there's a little red circle up here that says whether you saved or not, which I just looked at and saw that I hadn't saved. So save it now. And now I can output 1, 2, 3, and so on. And if we come up here to this code right here, we can copy this into the browser. And this will give us a list of all the different key codes. So if you want to use like the right arrow, we can just come down here. Ooh. Do this instead. All right, let's actually make this make more sense. So the first row, this should be the up arrow. And then we get to the next row, and this should be the left arrow, the down arrow. And then what do I want to do with the other 2 keys? We can leave the other 2 keys for now. So if we save that, I can now actually make a little D-pad where I can move around. And you can see me typing out down here. So yeah, that's how you get the keyboard to work. And then so lastly, if you wanted to personalize it, so say you wanted to do controlling zoom, you would Google zoom keyboard shortcuts. And so we're on Windows. This page isn't helpful, so we'll Google something else. Hotkeys in here, maybe? Yes, perfect. All right, so in this case, we want to send multiple key presses. So how do we do that? So let's go back here, and we're looking in the code for the HID library. And so a good thing to do is get good at reading the documentation. So we are in the documentation for the HID library. So if we read through here and we're looking through some sample code for keyboard shortcuts, so it looks like we can use kbd.send. I just kind of skimmed through this real quick, but I saw send alt tab, which we want to do. So it looks like you can send comma separated values. So kbd.send. So instead of this, we have to modify our code a bit. maybe we could do. So we're going to ignore the code that we wrote here, and we're just going to delete it. And for now, we'll just do, so this is a Boolean. If any key is being pressed, we're just going to send, is it shift? I can't remember actually. Left shift, okay. We'll send left shift, and I think the letter T, yeah, it's just T. And if I do this, and I press any key on the keyboard, I should just get a capital T. Perfect. Or you could do something like, maybe you had A, B, C, D. All right, needs capitalized. Another little bit here is that everything in programming is case sensitive. So capital A exists in here. Lowercase a does not. So actually, sorry. I'm going to redo what I did. I'm going to copy this to my clipboard, and then I'm going to undo all of this real quick because I want to get back down to the code that I had down here. What was this code? I'm going to paste that back. Oop. Paste that back in. And so now we're going to send keycode.left shift and whichever key is being pressed. And so now we can just caps lock or send all of the keys uppercase. Didn't even type them in order. Whoops. Anyway, you get the point. So yeah, so with this, along with lists of keyboard shortcuts, you can begin to control the BYO keyboard to do what you want. And from here, you could begin to write like more advanced tools that, like, instead of using key presses, there's the media consumer library. Like if you go back out to GitHub, painless prototyping BYO keyboard, you can find media controls, which will talk into the consumer control, which lets you do cool stuff like skip to the next song, increase volume, play pause. And so you can find all those examples here. At any point, sorry, so I should say those, so that's really it. That is the BYO keyboard and how to set it up with code and how to connect it all together. So if you have any questions, feel free to join the Discord server, and you can find the Discord server if you go to painlessprototyping.com and go to social and go to Discord, and this will launch Discord, and you can come in here and you can ask questions about learning circuits, learning soldering, all that good stuff. And I will be happy to answer your questions there. And yeah, so that's all. Thanks for joining me, and I will catch you next time.